Probability of dependent events. Let's make sure we understand the definition of dependent events. When a probability question is asking about multiple steps, if the outcome of one step affects the possible outcomes of another step, those are dependent events. So let's look at some examples and talk about it. Flipping a coin twice. These are not dependent events because no matter how many times you flip a coin, it has no effect on the next flip. These are independent events. Choose 5 lottery balls without replacement. Whenever you see without replacement, that's dependent events for sure. If you don't put the first lottery ball back in before you draw the second one, it has changed the number of balls available. It has also changed the numbers that are available. And so those are dependent events. Choose 2 students randomly. If you're choosing 2 students and we want them to be 2 different people, then the first choice has an effect on the probability of who gets chosen for the second choice. So these are dependent events. And next, spinning a spinner. This is also like flipping a coin because every time you spin a spinner, the probability starts over. The outcome of one spin doesn't do anything to change the possible outcomes of the next spins. So those are independent events. So we'll be looking at these kinds of events in this video. Here's a situation where you've got a bag of tiles. 3 are red and 6 are yellows. So that's 9 tiles in the bag. 2 tiles are drawn without replacement. So that means you draw the first tile, you set it aside before you draw the second tile. Here's how it affects the probability. If you remember the slot method we talked about before, the probability of pulling out red the first time is just 3 out of 9, right? Because there's 3 red tiles in the bag. But then how many red tiles are there in the bag now? One of them's missing, so now you only have 2 to choose from. Similarly, in the bag of all tiles, there's only 8 tiles left to choose from. So you can either think of it as all my choices for winning are 3 times 2, and all my choices in the whole bag are 9 times 8, or you can think of it as 3 out of 9 and 2 out of 8, and you multiply them together to get the probability. Either way, it comes out the same. I'm not going to do any cross-reducing, but I encourage you to reduce wherever you can. I just want to focus on the probability. So this is 6 over 72, and that reduces down to 1 out of 12. That's the probability of this. Remember to write both of those in your answer. So probability of red equals 1/12. Okay, let's calculate the second probability. What's the probability of yellow followed by red? Well, for yellow, we have 6 ways to win out of 9 choices. And for red, we have 3 ways to win, but there's no replacement here. So now we only have 8 because a tile has been pulled out in that first step right there, and it hasn't been replaced. So let's multiply that out. I get 18 over 72, which is equal to 1 out of 4. So the probability of yellow, red is 1/4. Here's another one. Let's say we want a 3-letter code created from the alphabet with no repeats. This is just like no replacements. These are dependent events. We're looking for the probability that everything is a vowel, and we've got 3 letters we're choosing. So how many vowels are there? There's 5, and after 1 has been chosen, there are 4, and after those 2 have been chosen, there are only 3. This is what happens when there's no replacement or no repeats. You see the decreasing numbers across the top. The same thing happens in the denominator. We started out with 26 letters available, and then we only had 25, and then we only had 24 because there were no repeats available. So whatever letter got picked the first time is not available when you pick the next letter, and the first 2 chosen are not available when you choose the last letter. Even though we don't know what those letters are, we're talking about how many options to calculate the probability. So now let's multiply that out. Remember, cross-reducing would be great here. So I'm going to go ahead and do some of that. How about 4 goes into 4 once, 4 goes into 24 6 times, and 3 goes into 3 once, 3 goes into 6 2 times, 5 goes into 5 once, and 5 goes into 25 5 times. This is pretty messy, so let me rewrite what's left just to be clear. I've got 26 times 5 times 2 in the denominator, and that's pretty easy to calculate. If you think of 10 times 26 is 260. So this is the probability of pulling all vowels when you pull 3 random letters out of the alphabet without repeating any of them. Pretty hard to guarantee that that's going to happen. And that gives you an idea of how dependent events are different than independent events. Look for those decreasing choices. That's the important part.